doing all of them at Panera. Panera has this thing called the Sip Club. And the Sip Club, the first month it's either free or $6 a month for like the first 3 months or whatever, but then it goes to 15 a month. And what it gets you is unlimited coffee, soda, those kinds of drinks, not like lattes, but like this is their pomegranate iced tea. It's like almost a $6 drink. So that's like a $6 drink for free. So I go in, I had my first meeting at 6 a.m. this morning. So I got my coffee for free. I was there for a couple hours. So right before I leave, I go into the app and I order my tea. You have to wait. There's a 2 hour gap before you can get your next free drink. So I leave. So every single day I get, well, let's say I'm there 4 days a week. So I get $10 of value 4 days a week. That's $160 a month for $15. Yeah, pretty legit. Well, I mean, it's un the cost per drink gets down to like a nickel or something like that. All right. A couple of announcements. Next week, there's only like 3 people who typically are online. If you are able to attend in person next week, that would be very helpful. If you are someone who is remote or has a time conflict, we can work something out. It's not the big end of the world, but if you are able to attend in person next week, that would be helpful. We're going to be doing an activity in class on Tuesday and Thursday, kind of like a mini hackathon type thing with exercises, functions that you're going to be writing, kind of individuals, but as a group with collaboration. We're going to get some CS students in here to assist. I'll be out of the country next week, so I won't physically be here, but we will meet, and there will be people running the thingamajig, and you'll be doing course-related practice. So with that in mind, I went through and I've disabled several of the assignments. I didn't like several of the assignments that the book produces, so I might rewrite some of them. But if you've already started this week's, that's fine. But I might take the one that's due next week off or push it a week so that you can focus on the things that we're doing from class, because there'll be like an extra credit component if you wanted to do more after the class is over. You have a question?
Where you go?
Oh, I am going to be in the middle of the Caribbean on a cruise ship. So, well, my wife and I do about 7 a year. One of my businesses is called Cruise Optimization Lab, and I teach people how to play the statistical casinos for their loyalty program to get free cruises. I haven't paid for a cruise in years. All right. Yeah, so if you go to cruiseoptimizationlab.com, that's one of my businesses. All right. So let's keep trucking here. I think we did finish our program last time. Let me just confirm that we didn't um, leave it half done. Are we working with this test thing? Yeah, this is what we wrote last time, the decimal to base. So down here. Now, remind me, I had a slide here that said all programs begin and end with main, wherever I put that. All programs begin and end with main. What do I mean by that? We only kind of talked about it out loud, so it's probably still a little fuzzy, but it's an important concept here. Go ahead. Okay. So again, to keep reiterating this idea that programming is the skill set, the language doesn't matter. So we happen to be using Python in here. I've been giving Java or C++ examples of some stuff, but the language really doesn't matter. So this is really kind of a core concept of programming. Modern programming languages, anything from the 1970s on, we're going to call that modern. The program starts off by, you can think of it like hiking the ball to the quarterback, which is the main method. So when you press start on your program, regardless of how, I mean, modernly you go into something, you hit a little play button, but historically you would compile it or run it from an interpreter at the command line. It would run the program, do its thing. When you first run the program, what it does is it immediately jumps to line 1 of main and just starts going. Now, if main says call this other function, well, then it's transferred control to some other part of your program. It goes and cooks there for a while. Once that's done, it comes back to, where the pass was thrown from, where it redirected it. All right, so I want us to always kind of keep that in mind, that every single program begins and ends with main. Now, scripting languages like Python do let you get away without explicitly putting a main in there, because since it's an interpreted language, it'll just go from the top to the bottom. So it kind of catches it. But we forced a main in last time. Oh, let me get the person admitted. So we see down here on line 73, I put this little if statement. If underscore underscore name underscore underscore, this guy right here, anything with 2 underscores before and 2 underscores after in Python is kind of like a reserved thing. Okay, these are keywords that represent different things. And name is the starting function, the function you're currently in. And by default, the Python interpreter sets name to main. That's where you're starting your program. So we know by the evidence is that in fact, main or Python does start at main. We see it through the evidence of this, even though we're not forced to do it on small Python scripts. But we're going to be using Python from the perspective of we're building bigger programs. This is just kind of our core part of our program. So we're going to get into the habit of always including a main so that regardless of when we move from one language to another, we're used to seeing that. Sometimes you do have to look a little bit under the hood. So for instance, if you're working with like writing an Android application or an iPhone application, a lot of times the first place you write anything is inside of a function called like onCreate. So you might have a function called onCreate that gets called automatically when the first screen of your app is created. But somebody called onCreate. All right, so when your Android app first launches on your phone, your iPhone app first launches on your phone, it starts at main. Main then does all the stuff that is required to get your app loaded inside of its little virtual machine to protect it from you crashing other parts of your phone. And then ultimately it calls onCreate, which lets you set up stuff that will be visible as soon as your app is finished loading. So there's like an onCreate, so what on will appear, on did appear. So you have different little moments you can interject. So if you want something to start happening as soon as your app actually has appeared on the screen, it would be inside that function called on did appear. But it started off 2 functions ago being called from main. Even though when you're writing Android stuff, you probably would not dig under the hood enough to get down to main. But if you wanted to, you could. The code gets generated for you. All right. So we've been writing more complicated things. We've been introducing ourselves to a couple of different types of constructs. So we've been looking at variables, single element variables, and then collections. So right now the collections that we officially know about are strings, but we also have this kind of collection of a thing called a list, which we've kind of accidentally used a couple of times. So we're going, and strings and lists kind of work interchangeably, but we're going to experiment a little bit with this today. But a lot of the skills needed to work with lists are the same as working with strings. Strings just have more stuff built into them. And that's true in most languages. I probably mentioned last time that Sorry, we got a distraction from a text message. I think we mentioned last time that certain languages are kind of string-based languages. As human beings, we work with words pretty often. So that's a very comfortable place. So the idea of having a variable type that can allow us to hold collections of characters makes a lot of sense when we have human beings solving problems. So those things, strings are almost always built into our modern programming languages. So they're almost always our very first object type. Now, what's the difference between a primitive type and an object type again? It's on one of our slides, but I won't go hunt for it. But what is the difference between a primitive type and an object type? Go ahead.
I think primitive was where you could only store one type of data set, where a object type is like you can have a name for it and put anything within that variable.
Okay. Well, I think we're on to some good stuff there. So let's update primitive to think a primitive can only hold a value. That's all it can do. Okay. Usually it's these types built in the language, our int types, our floating point types, but all they can do, a primitive type can only hold a value. Go ahead. Oh, tell me what question you're answering. This is like Jeopardy. Yeah, so you've just given me an answer. What's the question? No. She answered primitive types right, that it's a variable type built into the language that can only hold a value. Now you gave me an answer that is an answer to something. You said boils down to a single value of true or false. What is the question that has the answer of boils down to a single value of true or false? Boolean expression. So what's a Boolean expression? Any expression that boils down to a single value of true or false. And the reason I keep iterating that same cadence is often as you get further and further into as your programs get more complicated, your Boolean expressions at a glance will start looking more complicated, even though they ultimately do boil down to a single value. And that's going to kind of come with your experience in working at code, where as you look at code, you start tracing through a program. In fact, on like the midterm around week 8, some of the kinds of questions I'll ask is I'll give you code and ask you, what does this do? And I'm not asking you to go line by line and say, well, this assigns the number 7 to an integer. I want you to tell me in like a sentence or two, what do these 14 lines of code accomplish? So you need to be able to trace through the program, resolving variables to their values, thinking about what, I'm asking this question here. There's a Boolean expression here. What am I trying to determine from this question I'm asking? So one of the skills you'll have to build as a beginning programmer is when you see code, initially it might look more complex than it actually is. So don't just jump to a conclusion that, oh, I can just do this with that, or I can do this other thing with that. Slow down and ask yourself, what kind of animal am I actually dealing with here? Is this a number? Is it a string? Is it a literal value that's already hard coded? Whatever it is, know what you're working with before you think about what's possible with this thing. And that'll just come with experience. Okay, so primitive types are types built into the language that can only hold a value. Well, what are object types? So what's the antithesis to that? Go ahead.
Object types multiple values and like run like functions.
Yeah, I think that mostly captures it. So object types can potentially hold more than one value. They actually don't have to hold any values if we don't want them to. All of our primitive types, since their only talent is to hold a value, they all will hold exactly one value. But technically, we could build our own object that doesn't even hold information. It just does stuff. All right, so primitive types would have the ability of holding 0 or more pieces of information. And then it also has the ability of having 0 or more kind of abilities, functions that can do stuff to things of that object type. All right, that kind of makes some sense. All right. So let me hide this. All right, so what I'm going to do is I'm going to go ahead and start a new, here. Did the code thing work well when we did it inside of Colab? I guess we can work with this. So we're kind of in the place now where we want to be working with practicing writing functions, practicing writing abilities that we can write once, call upon them multiple times. By changing the inputs we pass to it, we potentially get different results. Okay. Now, do all functions have to return a value? No. What would be an example of a function that might not return a value? If you were writing a function that accomplished something, what would be an example of some function that doesn't return a value?
Type of function or like what the function
This,
does?
yeah, what it does. Yeah, just make up a problem that the function is solving that wouldn't require a value get returned. Yeah, but mostly it's going to be display stuff to the screen. So let's say you took in a function that read in the person's first name and read in the person's last name, two strings, and we wanted it to display to the screen their first name followed by a space followed by their last name. All right. So maybe we say define display name. Make this bigger. Is that big enough? All right. So let's see. Can I make this thing hide? Nailed it. All right, probably make it a little bit bigger. All right. So we can say define display name. And we're gonna put some stuff. So what goes inside of this part right here when we're writing functions? The inputs. So we're defining a function right now. We're not calling this function yet. We're defining a function, and what we put inside of these opening and closing parentheses here is the things that we're going to need as inputs into this function in order to accomplish something. So we're gonna build a function here that we're calling display name. I'm telling you that the job of this function, so we'll put a little comment here, takes a first and last name and displays them to the screen in pretty format, something like that. All right, remember when you start in Python, when you start a program or a line with the pound symbol, that's a comment, does not get executed by the compiler. It's for human eyes only. So I just kind of describe what we're about to do. We're going to call it display name. It'll take in a first name and a last name. Did I have to call them F name and L name? Why did I call it F name and L name? Yeah, I name my variable something that's meaningful for what they're holding, right? I expect this guy to take in a first name and take in a last name. F name and L name seem to make more sense than like A and B, right? Where you don't really know what, you could spell it out more. You could say first underscore name or something like that. All right. And then we're going to say something like, let's remind me, what's concatenation? We talked about concatenation last class. What's that guy for?
Do strings together.
All right. So concatenation is for building strings, right? We use it to build up strings. So in this case, I want to build the string that is whatever their first name is, followed by a space, followed by whatever their last name is. And then I want to take that string and I want to display it to the screen. Now we could do it all at once. We're going to look at a couple of ways of doing it here just to kind of connect some dots of things you've been doing in your homework. But I can go ahead and say answer is equal to F name concatenated with a space concatenated with L name. I can do something like that. All right. If I run this program right now, what will the output be? Why? I've defined a function. This guy, if I were to call this function and pass it a first name and a last name, so later on in my program, if I say display, like that, I'm passing in Mike for the first name, Littman for the last name. Those two things come in here. I'm creating a variable here called answer. I'm remembering something. What am I remembering? Whatever the current value of F name is, which in this example will be Mike, concatenated with a space, concatenated with whatever the current value of L name is, which in this example is Littman. So now answer will equal Mike space Littman. Okay, but what am I doing with the value of answer right now?
Store.
Only storing it, right? So I'm not displaying it or returning it or anything like that. So I'll go ahead and let's say we'll print out whatever answer currently is. So I've created an ability here. I build up my answer, then I print my answer. If I run this, I should get, oh, who? Oh, sorry. Display name. Although, notice display is built in. All right, so there's my output of me building up answer here to be my first name followed by a space followed by my last name. If I then call this guy again, maybe with Tony Smith, and I run this, we see that that same logic now works for different inputs. Okay, so this would be an example of a function that does not return a value, displays a value, right? Driving this point home that displaying something and returning something are two very different things. Now, what if I were to print out? Oop. What if I were to print out the result of calling display name on Tony Smith? What do we expect the output of this program to be? You think it's going to be what? Two Tony Smiths. Okay, well, first of all, let's go one line at a time. What's the output of this line going to be? Nothing's changed. Still Mike space Littman. Now, what's the output of this part of that expression? Tony space Smith. So what does print display here? So we're asking ourselves this expression, when you boil it down, what is the result of calling display name on Tony Smith? Nothing is being returned inside here. We are doing something. We're displaying it to the screen. So we know that Tony Smith is still going to appear on the screen, but I'm also trying to print out whatever that function returns. And if we don't have a return statement inside of a function, what does the function boil down to? None, nothingness. So there's our none. Prints out Mike Littman first, prints out Tony Smith second, then this display name for Tony Smith naturally ends. So after it's displayed Tony Smith, we hit the end of that function. It's now ended. We never returned anything. So the default behavior is the result of a function that doesn't return a value is none. Nothing is returned. And we see that result there. Probably not something we want to work with, but we now know that we can detect whether a function returns something or not by checking to see if it's equal to none, if that was helpful. All right, now, go ahead and take that off, make sure this guy still runs. All right, so now what if instead of printing answer, actually, let me go back and I'm going to leave this in. So let's say I do print answer like I did before, but then I go ahead and I also return answer. Are you allowed to print something and return something in the same function? Sure. Probably don't want to have the return come first. So if I did this, this would be problematic because what does the return keyword do? Yeah. Potentially returns a value, but definitely causes a function to end immediately. You don't actually have to return a value. We could just say return like that. And then that method will just die. Still have a value of none, but we will never get to this line of code. So if we run this, we see that our answer was none. We called display name here, Mike Littman. We built our answer, but then we ended right here. So we never got to a print. this guy doesn't say to print anything, right? The second one, we call in Tony Smith. We get Tony Smith stored in answer, but we don't do anything with it. Instead, we immediately return, so we never see a Tony Smith here. But this print is what this guy boiled down to the second time, which is none. That's why we don't see any of these answers here. All right, that makes some sense. All right, so now, so you probably wouldn't have a return sitting in the middle of your program. You return once you finally have your answer. And a majority of the time you use the return statement, it will be to return a value from a function. But every now and then you'll use it because you just want to get out of this function. You're done doing whatever you wanted to do. And rather than tricking your loop or whatever to finish running, you want to just get out of Dodge. And you can just say return. All right. So we now have this. No, no, no. All right, we now have this function that prints some stuff but doesn't actually return anything. Now, if I wanted to write display name, a second version of display name. So let's look at display name 2. Based on what you've learned so far, what is another way that we can write this program to have the same output?
Hard code the actual name into the arguments.
Tell me, you mean like up here?
Yes.
Okay. Yeah, you probably would never want to do that. So let's look at that though. This is a very common beginning programming mistake. We are writing this function to work on generic inputs, yet we're not giving it generic inputs. We're hard coding values. I mean, first of all, it's an error to begin with because the parameter list expects there to be parameter, variable names. We're just hard coding stuff in there, which means even if this wasn't an error, it doesn't matter that I'm passing in Tony for this first one thing if I'm just always setting it to Mike, right? It should always be a variable of some kind. So if we leave it like this, and it's display name 2, and I want to have the same physical output in that it should be whatever the first name is, followed by a space, followed by whatever the last name is. What is another way we can accomplish that output with stuff you've learned so far?
I don't accept the answer.
Hmm.
I'd accept the answer.
Just give me the same output. You don't have to set answer, so here, we'll get it started. We could do this. We didn't need to actually store it inside of a variable, right? When do you use variables? When you need to use something more than once, right? So if we need to remember a piece of information and we're going to use it here, but we might need it again in a little bit, we want to put that inside of a variable. In this case, we were only using that thing one time, so we could just say, I'm not going to put it inside of a variable. I'm just going to go ahead and print it directly. All right, so that is another way of doing that. Is there another way you know of that we can do this without using concatenation?
Formatted string.
Formatted string. So we can do something like, we can print out something that's going to be an F string, a formatted string, and this guy is going to be first name, followed by a space, followed by last name. And we'll call it display name 3 on these guys. So here's me calling display name 3, which is calling this guy right here. And instead of concatenating some stuff together, we are using our F string to build that answer. Still not storing it anywhere, but now we can, so F strings allow us to have outputs, typically visual things for the person that keeps us from having to have a whole bunch of various things all strung together with concatenation. One or two, two things glued together with concatenation, not a big deal. But what if you had 15 variables and you were creating this whole sentence output, and all of a sudden you're now gluing these things together with a zillion plus signs? Would get kind of annoying pretty quickly, right? All right, so we have different ways of accomplishing this. All right, so that would be working with things that either, so this would be an example of something that does something but doesn't return anything. Perfectly valid legal functions. Just understand that some functions accomplish a task but don't give you an answer. Some functions, their job is to do some stuff and then ultimately give you an answer. Probably the rarest breed of function is one that takes something in, does some stuff, displays it, and then also returns it. But maybe you'd have a function, and let's say this function is making a bunch of what would be called API calls. Let's say you're sending stuff to, ask for data for some external source or whatever. You might want to put some, display function so that the user kind of sees that the process is going, sending request, waiting for response, received response, processing, then it finally returns the value or something like that. Maybe you spit out a done or whatever, kind of give you a progress report sometimes, and we'll start writing these eventually, but usually when you're making calls to some external data source, you want it to do something for you. You make what's called an asynchronous request. You say, all right, I'm going to ask you for something. You get back to me when you're done. I'm going to keep my program running here so the user can do other things that they want. And you just notify me once you have your answer, and then I'll display stuff on the screen for my user. So that would be something called a non-blocking call. And we'll see those by example once we kind of get to that point. All right. So I want to add something. How do I add? Isn't there usually a plus? Oh, there we go. Nailed it. All right. So let's look at some examples of things we might want to do with strings. Let's assume that I have a function. We want to write a function that takes a string as a parameter and returns that string with all vowels removed. So vowels are A, E, I, O, U. So that is A, I, O, U. So that means whatever the string we pass in. So for example, if we pass in hello, what we should get out of this thing is HLL. The string with all the vowels removed from it. Make some sense? That's what we want to accomplish. All right. So go ahead and take 3 or 4 minutes and take an initial stab at this. I know might take some of you longer than that, but take a couple minutes, start thinking through how you would approach this particular problem. We want it to be generic, so I'll even give you the header. So this is going to be define, remove vowels. Maybe this takes in a string called the string. And inside here, we should ultimately return whatever string that was passed in with all the vowels removed from it. So using only what you know how to do so far, try to think through how you would accomplish this or go ahead and write it. And I'll give you a hint. We know how to build strings. We don't know how to take things out of strings. So you might need to build a new string, only keeping certain things. All right. So let's think about this a little bit. Um, let's break it down into pieces. Would it be helpful for us to have a little tool that allowed us to detect vowels? That'd be handy, right? So before we even write remove vowels, what if I want to write a function is val? And maybe this guy takes a char as a parameter and he returns true if that character is one of the vowels and returns false otherwise. How do we do that? How would you detect if a particular character, if I handed you inside of a little box some character and I asked you to tell me true or false, what's in that box is a vowel or isn't a vowel? Good.
Oh, I meant that. Just with all the values on top of it. Oh, like a very, like people values.
Okay, so we could create a variable. Maybe we actually just call this, let's call this guy vowels. So vowels is A-E-I-O-U, A-E-I-O-U. So that is all of the vowels in upper and lowercase, right? So we know that HR, we want to return true if HR is found somewhere in that list of vowels. We want to return false if it's not. So far, so good? All right. How do I check the contents of that string to see if HR, my parameter, my input, is found somewhere in that string? What approach would you take to doing that? Good.
For like, vowels, yes, to like filter through.
Okay. So we want to have some sort of loop that goes through stuff. I'm going to do it a slightly different way first. And the way you gave is a good answer, but let's look at it. I want to keep using while loops for a minute. So we're going to create a variable called pause. I'm going to start pause off at 0 because we know that vowels is a string. And how many characters are inside vowels generically? How do we generically say? What if this was hidden from you? You didn't see what was actually inside of vowels. The length of vowels, right? The length of vowels tells us the number of characters in vowels. You should likely never hard code values. If you're going to hard code a value, it should probably be for a good reason. In this case, we know that we're only working with vowels, so I'm going to put my vowels inside of a collection, right? And that way I can check things against that collection. Good.
So what's the difference between like the vowels and then like values -1? Is length of values
Well-
-1 for like orders and stuff?
Well, I mean, the difference would be the length of vowels. This is 1, 2, 3, 4, 5. So this is 10, right? So if I were to print out the length of vowels, I would get the number 10. If I were to say the length of vowels -1, I'd get the number 9. Why do we need the number 9? 9 is the last legal position inside of a string because strings are indexed starting at bucket 0. So something that has 10 characters in it is indexed 0 to 9. So that's where that length -1 thing comes in for us from a problem solving perspective. If I want to get this capital U there, and if I were to say I want to print vowels at bucket length of vowels. Length of vowels right here is going to give me a 10. So that'll boil down to a 10, what I have highlighted there. So if that becomes a 10, what will vowels at position 10 give me? An error. There is no position 10, right? So we have to use the length to stay one short of that. All right, so we'll set pause off at 0 because the first place we're going to check, we're going to walk through our string one character at a time, right? We're going to say, is this HR? If it is, he was a vowel, return true. Is this HR? If it is, it was a val going to return true. If you get through the entire string and you never found HR inside of my string called vals, I will fall out of the loop naturally. And if I'm still alive then, that means I didn't bump into any vals. All right, so we'll start off with pause is 0, while pause is less than the length of vals. Less than the length, which means less than or equal to the length minus 1. Make sense? All right, so we'll start off at 0, go all the way up to and including bucket length minus 1. Each time through, we're going to ask a question. We're going to say if the current position in vals. So vals at bucket pause, that's how I usually would read that. What kind of value is that going to boil down to? What I have highlighted there, what kind of value will that be? Go ahead.
The first letter in vowel.
Do you know necessarily it'll be the first letter? It's going to be the pause letter. Pause presumably is going to change. So the first time through would be the first letter, then it's going to be the second letter, the third letter, the fourth letter. But what kind of animal is this? It's going to be a letter or character, right? So the thing, when I say vowels, square bracket pause, vowels at position pause, vowels at bucket pause, the thing that I'm going to find there is going to be some character because that's the stuff that I have stored inside of vowels, right? So this guy right here will be some character. And I want to check that character against the character I'm looking for to find out, is this guy one of those vowels? Is this guy one of those characters? So I'll say if that guy is equivalent to HR. Why is this a double equal sign instead of a single equal sign? What's the difference between single equal signs and double equal signs? Go ahead.
Signs are comparison.
Okay, so a single equal sign is the assignment operator. We assign whatever values on the right into the variable that's on the left. Double equal sign is the equivalence operator. We're comparing the primitive type on the left to the primitive type on the right, unless the double equal sign has been defined for object types, which in Python it has been with strings. We'll look at that later. Not important for us. But in this case, we're saying, is this char, is this primitive type equivalent to this primitive type? If it is, that means, if it is equal to it, that means that I just found some character inside of my string called vowels that matches the character we passed in. And if I only had vowels inside my string called vowels and I found a match, that means this guy must be a vowel, right? So I'll return true. Now, do I say else return false? Why is that a problem? Go ahead.
Your first letter starts with something that isn't a vowel, but then like the other 4 letters after that have vowels in them, then your entire statement is false.
Okay. So each time through this loop, loops repeat themselves, right? As I have it written right now, it repeats itself forever. Checks bucket 0 over and over and over again. So if we wanted to just put in our pause is equal to pause plus 1, doesn't change my question here. But right now we're saying if the character I'm currently looking at is equivalent to HR, return true. Otherwise, return false. Remember, return makes a function immediately end, which means as I have this written right now, we're only checking bucket 0. If bucket 0 is a val and it matches the val that's in HR, then we technically dodged the bullet and this worked. In every other circumstance, if it's not a lowercase a, I'm going to return false, even if it is one of the other vowels, because my else goes with this if, and I am returning false the very first time that Boolean expression boils down to false. So I'm not checking the rest of them. So we do not want to have a return false associated with that question. We want to say, keep going through my string, checking every single character. How do I move from character to character? By adjusting the value of pause. Pause started off at 0, then it becomes a 1, then a 2, then a 3, then a 4, yada, yada, yada. All right. Each time through, we're going to ask the question, is the character I'm was passed in here, is it equivalent to the character I'm looking at, which I know is a bunch of vowels? If it is, return true. If not, move on to the next character. That's the pause equals pause plus 1. So 0 becomes 1. We spin back up. Is 1 less than 10? It is. So we'll check the val at bucket 1. Is that equal to it? If it is, we'll return true. If it's not, 1 becomes 2. Spin back up. Is 2 less than 10? Yep, we're still checking real characters in that string. Keep asking her question over and over again. Eventually, pause will be 9. 9 plus 1 is 10. Spin back up. Is 10 less than 10? It's not. So we will finally fall out of our while loop. If I am still alive here, I did not find HR anywhere in vowels. So after this while loop, if I'm still kicking, if I never hit return true here, that means I've checked everywhere. I did not find a match for HR inside of my string vowels. Therefore, it's not a vowel. Therefore, I'm going to return false. Make sense? So now I have a function that I wrote that I can pass any character to, and it will tell me true, it's a vowel, or false, it's not a vowel. So before I write this guy here, and let's go ahead and add in our, with underscore name, actually, is it a string? All right, so that's our main method check that we're just going to start putting into all of our Python programs to reinforce this idea that all programs begin and end with main, even though it's technically not required at the exact moment. It'll make sense why we're going to be doing it as soon as we start building bigger programs. But for right now, we're going to go ahead and just test our isVal function. So we're going to print, actually here. So I'm going to call isVal, and I'm going to pass it an A. I'm going to call isVal, and I'm going to pass it a B. What will the output of this program be? It'll be nothing, right? So output's nothing. Why is it nothing? I'm calling isVal. I'm passing it the character A. A is coming in for HR. Here's my vowels. Here's pause is 0. We're comparing vowels at bucket 0 with a, which is a lowercase a. We're comparing that against the lowercase a. Those match. What do I do if they match? Return true. So this function immediately ends. It returns a true. What am I doing with that value? Am I storing it? Am I printing it? I'm doing nothing with it. I call isVal. I pass in an A. We know, we just follow the logic that this guy will become a true, but I'm not doing anything with that value. If I want to see that true, I would have to print the result that's coming out of there. Or I'd have to store the result inside of a variable and then use it someplace else. All right. Beating a dead horse, I get it. Super important that you get used to this idea of displaying something versus returning something and being able to work with those things. All right. So now if I run this guy, oh, that's nice that Do I have my if main equals the thing written weird? Or does this guy not use the main thing? That seems more likely. Give me a moment. Where is my this guy? I had that in string format. It's not a string. It's actually the name of a variable, not a string. There we go. So there's our true. Why am I only getting true for that guy? I'm not getting false for the next one. Didn't do anything with it, right? I could say the answer is equal to that. I'm still not going to get the false rate. I'm storing it, but I'm not doing anything with it. Then I could say print the answer. There's my false. Good.
So why does this work with like words? If I put my name in, it would give me a false regardless of if there's vowels in it.
So you're saying, what if you do that?
Yeah, it would still give me a false.
Well, it certainly would be a false. Is A equal to Mike? Is E equal to Mike? Is I equal to Mike? Is O equal to Mike? Is U equal to Mike? Is capital A equal to Mike?
Vowel apposition clause, so it would be.
Yeah, so that's A, E,
Oh,
I, O. I'm using the entire HR.
oh,
HR equals Mike in this example. So I'm comparing a whole bunch of individual chars against the entire string Mike. That is going to be false forever, right? So really, this wouldn't make a lot of sense for us to check to see if the word Mike, the name Mike, is a vowel. I mean, we can just do it and know it's going to give us a false. You know, but we pretty much know ahead of time that if we're given a name, it's not going to be a vowel. It's going to be it's a different kind of animal. All right. All right. So now we're getting our true and false for A and B. This one we're just printing it directly. The second one we're storing the result as it comes out, and then we're displaying that result if we were interested in it. All right. So we now presumably have a function called isVal, a little tool that we wrote that I can throw any char at and it will tell me true or false, this is a val. All right. So now we want to write our function, remove vals. So this guy will take in a string as a parameter. I just kind of use this naming convention. A string, somebody's sending me a string and I'm going to do something to that string. So it's telling me a little bit about what should get passed in here. I would actually say, and this goes to her question, this is what I would view as a weakness of loosely typed languages. If we were in a strongly typed language like C++ or Java or whatever, we would have our expectation up here to be of type char. Because it's strongly typed. We have to label the kind of value we're expecting. Where right now, we're kind of trying to get the idea across to the person calling it through our variable name that we really want you to give us a char here, but we're not holding you to it. You know, your results might leave a lot to be desired if you don't give us a char, but because it's a loosely typed language, we don't have a way of holding them accountable for that. All right. So, but a loosely typed language, we have to either call it correctly or put error checking inside of our function that says, hey, if you gave me something that isn't a char, I'm just going to scream at you. Otherwise, I'll do the logic as expected. We're not going to spend too much time error checking at this point. Let's focus on the high level, but that's the idea that's going on here. So remove vowels from a string. A string is a collection of characters. And what I want to do is I want to go through a string and I want to remove the vowels from a string. So the lesson we're learning here is that strings in most languages, in fact, we can really say strings in all modern programming languages are read-only. All right. You might be able to find a language out there that it has a caveat or has something built into it, but I think it's a good rule of thumb for us to assume that anything that is a string is a read-only thing. If we need this guy to change, we have to build a brand new one and only keep the stuff that we want to have in there. We can't just remove things from it. If you were treating your strings as a character array or a character list, you technically could go in and say, okay, I'm getting rid of this guy, so let's just collapse everything in. So you move everything after that gap over one and then put an empty thing at the end. But don't think about that for right now. Just strings are read-only. Good. It's going to do what we're doing here. Yeah. Although, let's think about that for a second. If you say you want to replace in a string, so one of the functions for strings is the replace function, and you say I want to replace in this string all occurrences of A's, what would you replace it with? Okay, except there is no such thing as the empty char. There's a such thing as an empty string, a string with 0 characters, but there isn't a such thing as an empty char, a char that is nothing. There's the char that is the space, right? So you're saying I'm going to find, anytime I find an A in this string, I want to replace that A with single quote with no space in it. Now, it's possible that Python will allow that.
It does.
It does allow that. But if we think about it from a Unicode perspective, there isn't a character on the entire Unicode character sheet that is a character with length 0. There are strings with length 0. So I would say from a programming practice perspective, you probably want to operate under the idea that there is no such thing as the character that is nothing. Even though the reason it works in Python is Python makes a very loose distinction between strings and chars. You can represent both of them using single quotes. Yeah, so hello and hello are basically the same thing in Python. Where if we were in another language, this first one would be illegal because the single quotes typically mean chars, a single character. Double quotes typically mean strings. So again, this is an example where Python, because of its looseness, it's allowed something to work that logically really should not work, but because it's treating it as a string. But now, having said that, I mean, let's just go down that path for a second. If I say S is equal to hello, like that. And then so I would say what S dot is replace a function of strings, or is it a well, here, I'll just look it up here real quick. Or does it operate on strings? Python replace function string dot replace. All right, so this guy, it actually will let you actually the replace function looks like it replaces entire substrings of it, not just individual characters. So it actually relies on you giving it a string. But in this case, if I'm going to say I want to replace every occurrence of bananas, so in this example, let's just go and write it ourselves. And it's string, oh, no, it's the name of the thing. What? I don't want this. Why am I not getting a, oh, whatever. Like I've gotten into some full screen setting, but that's fine. All right, so if I were to say, let me just get rid of this guy here for a second. And we'll go ahead and say S is equal to hello. And then I say print S. And then I say S dot replace H with nothingness. And then I print out S. Okay, that's what it. So this tells us everything we needed to know. So S dot replace H and a single quote, no space, single quote. This guy does not actually change S. It returns a new version of S that has everything that was in it before with all H's replaced with nothingness. That's what we're about to write. It's a version of what we're writing. Except it's owned by, actually what's funny about this, it's owned by the string class, but doesn't actually modify the string that called it, which is okay. It's just a feature of it. So if I'm a string and I call my replace function and I say I want to replace all A's with nothing, one option for writing that would be I am going to make a modification to myself. So after I call my replace method, internally I've now been updated. We're going to see that when we start writing our own functions. But instead, it's like, okay, well, I can call this on me so it gets access to my contents by me saying S dot replace. So it knows that S is equal to hello in this case, but it's operating on my contents. It's not changing my contents. We're instead producing this brand new string that is the old string with all the H's replaced with nothingness. And then we're returning that answer for someone else to do whatever with it. And we saw that right here, where if I print out S initially, it's going to print out hello. Then if I call S dot replace on H and nothingness, and then print out S again, we notice that S has not actually changed. But if I say S is equivalent to, so I'm going to overwrite S with whatever it's now changed to, then I get the missing the H version of that, right? So if I wanted to write remove vowels using replace, I would actually call replace multiple times for each one of my vowels and say, replace all the E's with nothingness, replace all the I's with nothingness. So if you want to see that, we can do define remove vowels. This guy takes in a string. We could say we're going to go through all the characters in a string. So we'll keep doing this with a while loop. So we'll say pause is equal to 0 while pause is less than the length of a string. So that while loop will take pause on a journey that we want to don't forget that we want to say pause is equal to pause plus 1 somewhere before that while loop finishes. So this will take pause on a journey from 0 to 1 to 2 to 3 to 4, all the way up to and including the length minus 1, and then fall out. And what do I want to do each time? I'm going to say a string is equal to a string dot remove. Okay, well, now I need to have my list of strings or my list of vowels that I have in my isval thing. And then I could say, well, I want to go through every element of that. So that was 10 times through. So I'd have another while loop inside here that goes through and it would replace, let's just say while pause 2 is less than length of vowels all right, so now we have all our vowels. So we're going to go through every character of a string. And then for each character of a string, I want to go through every character in vowels. And what am I going to do? I'm going to say a string is equal to a string dot remove vowels at position pos 2 and replace it with nothingness. So whatever vowel we're working with here, so in this case we have pos 2, we'll start pos 2. Actually, we can build it in here. This is intentionally complicated, by the way. So if you're finding this complicated, it's good. This is not the way we're going to do it. So we're going to have pos 2 keep track of where we are on vowels. We're going to say pos 2 starts off at 0. We're going to go through all of our vowels. Each time through, we want to replace the current value the current vowel we're looking at inside that string with our nothingness. Right now, we know that we're going to be going through our string once at a time. So we actually, once we have dealt with this guy, we can break out of this loop. We don't need to check the rest of the vowels, but we're going to do it anyways. So what we're going to do is we're going to replace all the characters, all the A's throughout the string, and we're going to do it 10 times. We're going to replace A 10 times, even though we only did the thing. So this is going to go through quite a few things, replacing the same letter in a string multiple times until we finally have those guys whittled out. Rather than building a brand new string from scratch that only has things in it that are not vowels. So this complexity we're seeing here is actually coming from us not using a tool like isVal, right? So we wrote a tool here called isVal that we can now use. So for remove vowels, I'm going to get rid of that. I'll keep the second guy here. We're going to have my answer be the empty string. We're going to be building up a result. So I'm going to start with nothingness. I'm going to start walking through my variable called a string. And every time I hit a character that is not a vowel, I'm going to keep it. Make sense? Every time I get something that's not a vowel, I want to keep it. So if isVal, and we'll make a change here. If isVal, when passing a string at bucket pos, if that guy is currently a vowel, I don't want to do anything with it. So really, I'm going to ask the question, and we're going to purposely use a Boolean expression that we probably wouldn't have said here. Programming wise, we probably would have said if it's not a vowel, but in this case, I'm going to say if isVal returns false to keep it working with the double equal sign here. So if isVal gives me a false, meaning the thing I just sent you is not a vowel. And if it's not a vowel, I want to keep it in my string because I am removing things that are vowels. So I want to keep things that are not vowels. So if it is not a vowel, I'll go ahead and say answer is equal to answer concatenated with a string at position pos. We'll make sure that we increment pos each time, only keeping the things that are not vowels. Each time through, we say, if you're not a vowel, I want to keep you. If you are a vowel, this guy will boil down to true, which means true is not equal to false, which means we'll skip this. So we're only getting into that if statement when we run into something that's not a vowel. And if it's not a vowel, what I want to do with it, I want to keep it, add it onto my answer. In the very end, we're going to go ahead and return our final answer, which should have all those guys removed. So if I say print, remove vowels from S, there's my HLL, all the vowels removed from that. All right, if I change this thing to have an E in it, a capital one, since my vowels also had a capital letter, it also removed it. Okay, so removing something from a string translates into keeping things that are not that. All right, I'll post a link to this code. I'll see everybody on Thursday. Copy link to sell.
Thank you.
Yeah. All right. So I put it in the slides, the link to that code.
Did we one day go over how